Welcome to myprojectbazaar.com.
Now we are going to discuss about the product, a feature learning and object recognition framework for underwater fish images. Now we are going to discuss about the abstract for the process. Live fish recognition is one of the most crucial elements of fishes survey applications where the vast amount of data is rapidly acquired. Different from general scenarios, challenges to underwater image recognitions are posted by the poor image quality, uncontrolled objects and environment, and difficult in acquiring the respective samples. In addition, most existing feature extraction techniques are hindered from automation due to involving the human supervisions. Towards this end, we propose an underwater fish recognition framework that consists of a fully unsupervised, hence the process is also in the semi-supervised features learning technique and an error-resilient classifiers. Object spots are initialized based on the saliency and relaxations labelings to match object spots correctly. A non-rigid part model is then learned based on the fitness, separation and discrimination criteria. From the classifier, an unsupervised clustering approach generates an binary classes hierarchy where each node is the classifier. Hence, we achieved the recognition rate as correctly to identify the type of fish. Now we are going to discuss about the flow diagram for the process. This is the overall flow structure for the process. At first, the image acquisition. Image acquisition is nothing but the getting the input image from the dataset. The dataset is the folder which consists of the several input images. After getting any one input from the dataset, the pre-processing is carried out. In this pre-processing step, the noise removal is done by using the suitable filters. After the noise removal, the noise-free image, that is the enhanced image, comes out from the pre-processing. After the pre-processing, the segmentation is done by using the k-means clustering method and then the bounding box segmentation. K-means is nothing but the clustering technique which can clusters the single image into an 1, 2 and 3 type of clusters, and the required region of interest is the bounded by using the bounding box. Here we have the 3 type of clusters. If the region of interest is detected, means the particular cluster only undergone for the feature extraction. Here the region of interest is specified as the fish region, and the other than the fish regions will be considered as a background, hence it will be eliminated. Hence, in the feature extraction method, we use the SERP feature extraction method to extract the feature points. After the feature extraction, the classification was done by using the multi-SVM classifier. In the multi-SVM classifier, we have to give the 3 things as an input: test feature, train feature and target. Test features represents the feature of the input image, train feature represents the feature of the all dataset images, and the target represents the type of the fishes. Hence, the SVM is abbreviated as a support vector machine. After the classification, the performance is done based on the precision and recall. By using the precision and recall only, we can justify our process is efficient. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2015 and change the current directory. If you want to execute the code, means just right click in the main.m file and select the option run. Now the initial GUI design was open. In that you can see the several push buttons in the left side for the controlling actions, and then the axis for the display purpose. First of all, click the input image and select the image from the dataset. After the selection of the image from the dataset, the corresponding image is shown in the axis 1 with the title input image. After that, the pre-processing will done. In this pre-processing, we have to resize the image first of all in the aspect ratio in the size of 256 cross 256. Hence the number of rows and the number of columns will be 256. After that, click the check button noise filtering. Now the noise filtering will be applied for the input image. Then click the button segmentation. Now the k-means segmentation will be carried out. In this k-means segmentation, the single image is converted into an 3 type of clusterings. Now the figure 1 shows the labeled image. Hence we have the 3 labeled. Zeros, ones, and then the gray levels. Now these 3 labeled images are splitted as an like this. Hence the region of interest is present in the second image, so that we can give the input as 2 and then give button apply. Now the region of interest only extracted, hence the other regions will be eliminated. These regions will be bounded by using the bounding box, and then the SERP features are plotted around this region. Now click the button feature extraction. Now the featured value which is extracted from the region of interest will be shown in the tabulator. After that, click the button classification. Now the classification result will be shown. Now click the button first of all KNN classification. Now the fish type will be shown in the message box, also in the KNN classification result. Then click the button SVM classification. The corresponding result will be shown here. At last, finally, click the button estimation. After clicking the button estimation, the new GUI design was open. Now the performance like accuracy, sensitivity, specificity, error rate, positive predictive value, negative predictive values are shown in the bar chart, and then the comparisons between the KNN and SVM will be shown here in the figure 6. The blue color represents the accuracy, green represents the sensitivity, and the yellow represents the specificity. Now the corresponding values are shown here.
Thanks for watching this video.